So welcome back. The first two problems here are just practice problems for square roots before you start the cube roots. So go ahead and stop the video, try them, and then tune back in and you'll see the answers. And so here's my work and the answers. So the answers are in the box. So if you got one wrong, stop the video, analyze my work, and see if you can figure out what you did wrong. If you can't, ask for help. All right, so what I want you to do now is just fill in the perfect cubes column, just the very first column. So stop the video and do that because you know them. Now take a moment to make sure that you filled them in correctly, and remember, you should have those memorized. So if you don't, make sure you commit some time to studying. So now let's just review again why these are perfect cubes. So 2 cubed is 8, and the cube root of 8 is 2 because 2 times 2 times 2 is 8. And the cube root of 27 is 3 because 3 cubed, or 3 times 3 times 3 is 27. The cube root of 64 is 4 because 4 times 4 times 4 is 64. One more. Cube root of 125 is 5 because 5 times 5 times 5, or 5 cubed, is 125. So now, if we're looking over here at which ones of these are perfect cubes, well, we're thinking, well, which ones can I break up into 3 of the same exact numbers by multiplying? So let's think, x squared. No, I can only do x squared, x times x for that. That's not 3, but I can for x cubed. X cubed is the same as saying, or x times x times x times x. So that one's a perfect cube because there are 3 of the same exact numbers multiplied together to give you x cubed. The next one is x to the 6th, because think about it, I could break this into x to the second times x to the second times x to the second. Or we could even say that's just x to the second to the 3rd power, right? X to the 9th, we can break that into x to the 3rd times x to the 3rd times x to the 3rd. Or we can even say that's just x to the 3rd to the 3rd power, which is just the same as x to the 9th. So those are my only perfect cubes. So now let's look down here. A variable raised to a power that is a blank is a perfect cube. Look at the exponents on those. 3, 6, 9. What's the next one going to be? X to the 12th. So it's a multiple of 4 is a perfect cube. What you're going to put there? Multiple of 4. Of 3, not 4. I don't know what I'm talking about. Multiple of 3 is a perfect cube. So now let's look at simplifying these. The cube root of x squared, well, you can only break that into x times x. That one's already simplified. Already simplified. My handwriting is terrible with these little pens. All right, the cube root of x to the 3rd. Well, look, over here, the cube root of x to the 3rd has to be x because x times x times x is x to the 3rd. The cube root of x to the 4th, that's not a perfect cube, but you can break that into the cube root of x to the 3rd times x. You have to really listen to me because my handwriting on this is not working out. And so now, if you think about it, x to the 3rd is a perfect cube because we just found the cube root of x to the 3rd, that's x. So this is going to be x cube root of x. And then make sure you put that little 3 next to the radical symbol to note that we're doing cube roots. Now, x to the 5th. That is not a perfect cube because x to the 5th is not a multiple of 3. However, we can break that into x to the 3rd times x to the 2nd because it isn't x to the 3rd times x to the 2nd, x to the 5th. So then we have a perfect cube in there. That's x to the 3rd. The square root of x, or the cube root of x to the 3rd is x cube root of x squared now. Little 3's go on the little cube radical symbols. The cube root of x to the 6th is x to the 2nd because we just said over here x to the 2nd cubed is x to the 6th. So now the cube root of x to the 7th. 7's not a multiple of 3, however 6 is, right? So we could break x to the 7th in the cube root of x to the 6th times x. Right? Which means that the answer would be x to the 2nd cube root of x, because you're taking out the cube root of x to the 6th, which is x to the 2nd. The cube root of x to the 8th. Again, 8 is not a multiple of 3. So we're going to do x to the 6th times x to the 2nd, right? Because isn't 6 plus 2, 8, right? And x to the 2nd we know is done. The cube root of x to the 6th is x to the 2nd. And then you're left with the cube root of x to the 2nd on the inside of the radical. Now, the cube root of x to the 9th. That's a perfect cube. Because 9 is divisible by 3, we get x to the 3rd. Another reason, if you think about it, when we're cubing something, we're multiplying the exponents. That's why it's always multiples of 3, right? So if we're finding the cube root, we're just dividing the exponent by 3. That's it. Now x to the 10th, not divisible by 3. I keep forgetting my little cube root symbols up there. Not divisible by 3, but x to the 9th is, so you can break it into x to the 9th times x. The cube root of x to the 9th is x to the 3rd, and you're left with the cube root of x. Cube root of x to the 11th would be cube root of x to the 9th times x squared, which is x to the 3rd, cube root of x to the 2nd. Now look, all the ones that aren't perfect cubes, what we're doing is you're either leaving an x on the inside or an x squared on the inside, an x on the inside or an x squared on the inside, an x on the inside or an x squared on the inside. And then what's left on the outside is a third of the number that's closest to a number that's multiple of 3 right before it, right? So here I left 1 in because there's just 7 is 1 away from 6. 8 is 2 away from 6. Here, 9 is 1 away from 10. 9 is 2 away from 11. So you're always going to leave an x or an x squared on the inside, and then you find a third of the one before it on the outside. So now when you're simplifying these things, you're going to simplify them just like you would perfect squares, except we're going to use perfect cubes. And we're going to stay away from the tree for this one because the trees on these can get super, super big. Let's just try to find perfect cubes that go into these numbers. So let's look at the number 56. Look at the list of perfect cubes you just made up there. What perfect cube goes into 56? 8. So you're going to break this into the cube root of 8 times 7. And the cube root of 8 is 2. So this answer is 2 cube root of 7. And you're done. Because there's not a perfect cube that goes into that. So you're trying to find the largest perfect cube that goes into the number. So you just try them. Get out your calculator and try them if you can't see it immediately. But number 2, you should be able to see the perfect cube in there. It's 64. So you're going to do the cube root of 64 times 10. And the cube root of 64 is 4. So you get 4 cube root of 10. Done. Number 3, I'm going to try 125. 125 times 5. So I'm going to say that's the cube root of 125 times 5. And 125 is my perfect cube. That's 5. The cube root of 125 is 5. Cube root of 5. Number 4. Go ahead and just start taking 448 and see if you can find a perfect cube, the biggest perfect cube that goes into it. So you should have found 64 is the biggest one that goes into it. So you would get the cube root of 64 times 7. And the cube root of 64 is 4. So you have 4 cube root of 7. All right, on to the back. Trying ones with exponents and variables in here. So the way I like to do these is I like to ask myself, is this number a perfect cube? If it's not, I'm going to break it up. If it is, I'm going to leave it alone for a second. So I like to just start the problem like this. I'm going to draw my cube root symbol, and I'm going to say, is 54 a perfect cube? It's not, so I'm going to try 8, and I'm going to try 27. And I'm going to see that 27 times 2 gives me 54. Is x to the 6th a perfect cube? Yes, because the exponent is divisible by 3. And then I'm going to circle my perfect cubes. 27 is a perfect cube. X to the 6th is a perfect cube. The cube root of 27 is 3. The cube root of x to the 6th is x to the 2nd because you're dividing 6 by 3. And then you're left with the cube root of 2 on the inside. See how that works? All right, the next one. If you want to stop the video and try it, go for it, but you're looking for the biggest perfect cube that goes into 432, and then any of your exponents that aren't perfect cubes, you want to break them up into a perfect cube times what's left. So if you went through and did the problem, you would have found that 8 goes into it, so does 27, so that means the biggest one that goes into it is 216, okay? So let's go ahead and do it with the biggest one. So you have the cube root of 216 times 2. X to the 12th is a perfect cube because its exponent is divisible by 3. Y to the 4th is not, so you would break that into y to the 3rd times y. So now, circle your perfect cubes. 216, x to the 12th, y to the 3rd. The cube root of 216 is 6. The cube root of x to the 12th is x to the 4th. The cube root of y to the 3rd is y. And what's left on the inside is the cube root of 2y. Done. Now, if you didn't get that on the first try, look inside your radical symbol and see the number that you have left in there. Does another perfect cube go into it? And if it does, then you have to continue it, just like we did with square roots. All right, number 7. Again, stop the video, see if you can try the biggest perfect cube that goes into that. Again, I found that 216 goes into that big number 6 times. So I'm going to break this into the cube root of 216 times 6. X to the 30th is already a perfect cube. Y to the 31st is not, but I could break that into y to the 30th times y, just regular y. And so then my perfect cubes here are 216, x to the 30th, y to the 30th, and we're going to pull those out. So the cube root of 216 is 6. The cube root of x to the 30th is x to the 10th. We're just dividing the exponents by 3. The cube root of y to the 30th is y to the 10th, and you're left with, in the inside, the cube root of 6y. All right, stop the video. Try the rest of just the cube root problems, and then come back into the video to check to see if you got your answers right. All right, so now take a look at the answers for 8, 9, and 10. What you see in the box is the correct answer. What you see above the box is how I broke it up, and then I circled the perfect cubes, and then I pulled them out on the inside. So see if you can find your mistakes if you made any. So the next little section is just talking about working backwards. So it's going to be kind of like Jeopardy, where you have the answer and you're trying to get the problem. This is a good way to check your work, and some of you might already be doing this, but it's also a really good technique to use when you have a multiple choice question and you're asked to simplify a radical and then you're given a whole bunch of answers. You can always work backwards to find the correct answer. So if you take a look at the very first one, I'm saying that 4m square root of 3 is equal to square root of 48m squared. So let's think about it. When I'm simplifying 48m squared, I'm looking for the perfect square that goes into 48, and I pull it out, I find the square root of it. Well, the opposite of finding the square root of something is to square it. So if you think about it, like what was 4m before I actually took it out? Well, if you square 4m, that gives you 16m squared. So let's think about that. You're going to square the outside, put it back in the inside. So let's think about that for a second. So if I square 4m, I'm going to get 16m squared. And then there's already a 3 on the inside. If I just multiply that together, doesn't that give me 48m to the second? Let's try example 2. Example 2 is a cube root. Well, I found the cube root of something, so if I want to know what it was before I pulled it out, you have to cube it, right? So you're taking this thing right here and you're cubing it. Well, 5 cubed is 125. A to the second cubed is a to the 6th, and then you're just putting that back in there with a 2a. If I multiply all that together, doesn't that give me 250 a to the 7th? So let's go ahead and try a couple. 2 square root of 3. Well, what was 2 before it came out? It was a 4, because if you square 2, you get 4. So inside the radical, I would put the 4 back in and multiply it by the 3, and you get the square root of 12. So the unsimplified version of 2 square root of 3 is 12. But if it's a perfect cube, or if it's a cube root, sorry, then you're cubing the 2. 2 cubed is 8. You're putting it back in there with the 3. This is a cube root. 8 times 3 is 24. So this would be the cube root of 24. Done. The next one, 5x square root of 3. We're going to square the 5x. 5x squared is 25x squared. And you already have a 3 in there. That wasn't your perfect square. Put that together. That gives you the square root of 75x squared. Done. Number 4, 5x cube root of 3. We'll cube the 5x. 5 cubed is 125. X cubed is x to the 3rd times 3. And then just multiply all that together. That's a cube root. And you get the cube root of 375 x to the 3rd. Done. If you think you have it, stop the video and try the next 2, or the next several. So I'll keep explaining this row. So 8x, you're going to square that because it was a square root. So 8x was 64x squared before it came out. You're multiplying that by x, that was already in there, and your answer is 64x to the 3rd. The next one, perfect cube came out. So this, we're going to cube it. So if you think about that, you're cubing everything. 2 cubed is 8. M squared to the 3rd is m to the 6th. You're just multiplying your exponents. N to the 3rd. And then in there already, you have a 3, m squared, n squared. Put all that together, it's a cube root. And you get 24 m to the 8th, n to the 5th. Done. The next one. It's a square root, so you got to square the outside. So 3ab to the 4th squared is going to give you 9. A squared b to the 8th, and you're going to multiply that by the 6 that was already in there. 9 times 6 is 54, so you have the square root of 54 a squared b to the 8th. Now stop the video and definitely try the rest, because all you're going to get now are the answers. And so here are the last 3. If you are looking at my work, the very first term that's in there is me squaring or cubing the number, and then the second thing that's in there is the radical, what was already left inside the radical, and then I multiplied them together. So remember, when you multiply things together, you're adding the exponents. When you are squaring something, you are multiplying the exponents by 2. When you are cubing something, you are multiplying the exponents by 3. If you are not getting the correct answers and you cannot find your mistake, make sure you are asking for help.